heat waves, drought, tornadoes, hurricanes, floods, blizzards, bitter cold. Extreme weather has an incredible impact on people across the globe. On Mount Washington, our scientists braved some of the worst weather on the planet to improve our understanding of our warming world. All right, good evening and welcome everyone to Mount Washington Observatory's Science in the Mountains lecture series. My name is Brian Fitzgerald and I'm the Director of Education here for the observatory. Welcome, thanks so much for joining tonight. And joining us this evening to tell us all about the science and history of forensic meteorology is Alicia Wasula. Thanks so much for joining for tonight's program. If you're not already familiar with Mount Washington Observatory, we are a nonprofit member-supported organization with a mission to advance the understanding of the forces that create Earth's weather and climate. And we accomplish that through our around-the-clock weather observation and forecasting, by conducting research and product testing, and by developing and offering innovative educational programs. If you have questions for tonight's speaker, you're joining through Zoom, please make sure you use the Q&A button. You can find that at the bottom of your Zoom screen. We'll be able to collect your questions throughout the entire program and make sure to have some time at the end of the program for a live Q&A session, so make sure to get your questions in. If you're watching over on Facebook and weren't able to join us live, by all means, please join us next time and sign up through Zoom over at mountwashington.org and look for Science in the Mountains. All right, so before we kick things off, I am going to launch a poll here for everyone who's joining through Zoom. And so before we hand things over to Alicia, I want to make sure to get some of our questions in because we got some great trivia questions here from our speaker. And as always, if you're on Zoom here, you should see your questions popping up. We're curious where you're joining from tonight. Perhaps it's a state within New England, perhaps it's outside of New England, maybe very close by, or maybe you're joining from much further away or outside the country. And then our two questions from Alicia tonight. First, what is a CCM? That is an acronym that will be coming up here tonight. Is it a credentialed consulting meteorologist, a certified consulting meteorologist, or a commissioned credible meteorologist? And then finally, when was the first documented use of forensic meteorology in recorded history? Was it 1858, 1901, or 1925? I don't know the answer to this one. Really curious to see what you all pick, and we'll find out here in just a little bit. And it looks like a good amount of you have already participated, so we'll close the poll up in about 5 seconds here. And 3, 2, 1. Alrighty, let's go ahead and end the poll, and we can share out some results here. So, all right, New Hampshire just edging out folks from outside of New England. Great representation from Massachusetts as well, and representation from everywhere within New England, certainly from outside the region, and even one person joining from outside the country. Well, welcome to all of you, regardless of where you're joining from. I'll go ahead and stop sharing that. And since I'm really curious, and perhaps you're curious as well, I would love to introduce tonight's speaker, Alicia Wasula. Alicia, hey, I can see you. Can you hear me okay?
Yes, hi. Thank you so much for having me tonight.
Yeah, absolutely. Excited to have you. As I was telling you before we started, this is a topic I'm personally been so curious about, maybe slightly jealous. Maybe there's a career for me one day down the line here, but so excited to hear about your work and your pathway, how you got to where you are, and love to hand it right over. Go for it.
Sure thing. Okay, let me just share my screen here. And let's see, Brian, let me know you can see everything okay on the screen?
Looks great.
Great. Okay, then we will jump right in. And I hope that all of the answers to the trivia questions, they should be in the slides. So at some point we'll hit all of them that were asked. So yeah, thanks for having me tonight. It's a thrill to be here. I love talking about what I do because it's kind of an interesting little area of meteorology. So we'll talk about what it is and talk about some interesting cases that I have come across in my years of doing forensic meteorology. And definitely we'll save some time for questions because sometimes this generates a lot of Q&A. So who am I? I am the owner of STM Weather. We're based in upstate New York, so I live in Troy, New York, for those of you in New England who may know where that is, or those of you outside of New England who may know where that is. But my meteorologists on staff who you see here are located all over. So I have a couple in the Southeast and then one other one in New York here with me as well. We mostly focus on forensic meteorology, but we also do a lot of seminars such as what we're doing here tonight, community engagement. We talk at schools and things like that as well. So we do a lot of different things, but forensic meteorology is what makes up sort of the bulk of our day-to-day business, which is why I am here tonight. So we're going to jump right in and start talking about what it is and what a forensic meteorologist does. The bottom line is that we do research on past weather events. So don't ask me, anybody, please, in the Q&A what the weather's going to be. I have no idea. But I do look at the same kind of weather data that meteorologists who forecast the weather use, except I'm looking at events that already have happened. That's generally in the context of some kind of litigation, and we'll get into all the different types of litigation tonight as well. But sometimes general citizens need to have weather information about something that happened in the past as well. So it's, runs the whole gamut, although a lot of times it's related to legal issues. The approach is always the same in terms of how we construct what happened in the past. There's generally a research project. We do a lot of time in the beginning talking with our clients to find out what exactly the information is that they need. There's usually some kind of weather-related question. It could be just as simple as what happened. It could be something very specific, like how long did the snow last or how much fell? It could be a timing question. It could be a historical context question. And those are always kinds of fun cases to put together where you're looking back to see how common or uncommon a particular type of weather event was for a particular area of the country. Always in the context of litigation, especially, we brief our clients generally by phone. So when I'm giving these kinds of talks to student groups, I always remind students, if there's any in the audience tonight, work on your phone skills because I use them every day. We usually write a report in writing if that's something that's needed by the client as well. And then everybody asks, do you testify? Well, yes, but to be honest with you, it's pretty rare. Most everything that I work on settles out of court. And so my role is really just to provide information to the court. And really, it generally helps the cases settle. It helps the two parties come to an agreement, which is kind of the goal in the long run anyway. But yes, occasionally I do have to appear in court to testify about the weather. So I am a little bit of a history buff. When I started talking about forensic meteorology and when I first started getting into it as a career, I did a lot of looking backwards to see, what is this field really like? And it turns out that there's a pretty long history. So I want to hit some highlights. I have teenagers and, you're never supposed to tell your teenagers to look at Wikipedia, but I'm putting this up here because I actually really like the Wikipedia definition of what forensic meteorology is. It's the study of weather applied to the process of reconstructing weather events for a specific time and a specific location. And it mentions in the discussion about court cases, insurance disputes, and personal injury, all of which are things that I see in my day-to-day. It talks about the different types of data that we use, and we'll get into all of that as well. And it talks about the Certified Consulting Meteorologist program, which is run by the American Meteorological Society. That's the largest society of meteorologists in the country. So the Certified Consulting Meteorologist designation is a certification that you can get. You have to have a certain amount of experience, 5 years at least working in the field. You have to have character references. You take a written exam, you take an oral exam. And basically, once you earn this credential, it speaks to the court about your knowledge, your experience in the field, and your character, that you move and do your business in an ethical way. And of course, there's professional development. Like with any certification, I think you have to keep going and keep learning and participate in your field in a lot of different ways to maintain your certification. So there's your CCM answer right there. Certified Consulting Meteorologist. So there's an article in WeatherWise back several years ago now, June 2004, where it talks about the practice of forensic meteorology. And I really like this. Some of these articles, if you're interested, you can go back and look at them later. But it talks about the why, and why does it fall within private businesses to do this kind of work. And one of the things that Sean Potter, who is the author of this article, noted was that the National Weather Service can provide weather data, but they generally can't testify for cases in court unless it's involving the federal government in some way, and they may need to appear for those kinds of cases. It also talks about how a successful forensic meteorologist has to be both technically proficient, so you have to know your science, but you also have to be a good communicator. And a lot of what I do is explaining science to people who maybe don't do science in the day-to-day of their lives, attorneys, for example. So the communication piece is very important in what I do as well. And I just thought that was neat because that's from, over 20 years ago now. There's an article, again, written by two meteorologists, one of which, Elizabeth Austin, is a practicing CCM still today. And it talks about how a case is put together and the questions that may come up. And I think what you're going to see as we work through this part of the talk is that the questions that are asked of meteorologists when people need to know information about something that happened in the past, they're really very similar over the decades. The way that we approach the research has changed as research techniques and data have improved over the years, but a lot of these questions and a lot of the way that the problem is approached is very much the same. You can see there's an aviation one. We'll get into those as well a little bit, just when we talk about the different types of cases. But the role of the forensic meteorologist in a court case, again, is to provide an opinion to the court about the weather conditions based on an analysis of the weather data. So we don't advocate for one side or another. I may be retained by plaintiffs' attorneys. I may be retained by defense attorneys. I wouldn't work, obviously, for conflict of interest on the same case for both sides, but it doesn't matter. You're looking at weather data and providing an opinion about that data. I think this is the other answer to your trivia question here. This is perhaps one of the earliest references to the use of what you might call forensic meteorology in the legal system in the United States. And it's a famous trial regardless of the meteorology part of it. It's the Lincoln Almanac trial. And Lincoln, then much younger and not president yet, was defending somebody who was on trial for murder. And the prosecution had a witness that claimed that they saw this defendant from about 150 feet away by the light of the moon. So Lincoln went and got the Farmer's Almanac, which was like the weather data of that time. And he was able to show that the moon wasn't even really very far above the horizon and that it was in its first quarter phase. So it was just a tiny sliver. And partially as a result of him going back into the data to make this argument, the defendant ended up being acquitted, and it was a successful case for him and his client. So I like going backwards. Like I said, this is so interesting to me. I'm going to show you a series of slides here where we're going to look at past articles in some of the older meteorology journals that are still in print today. Monthly Weather Review is one of them. And this one I pulled from an article that was published in March 1900. And I underlined some of the key points here. This meteorologist noted that he had been to court 33 times to testify about the weather at a particular time and what bearing it had on that particular case. And he also noted that many of the cases that he saw were settled out of court. Sounds very similar, right? Here's another one from 1922. And again, I like just putting the old pictures of the journals. It's just really cool to see them. You don't have to read any of that language in the article, but it's there if you want to look it up afterwards. This article talked about different case examples. So for example, an automobile collided with a milk wagon and didn't have its lights on. So the question was, when is twilight? A woman was arrested for selling spoiled goose meat. We don't see cases like that, but we do see excessive heat cases, right? So how high was the high temperature? Were there warnings and that kind of thing? The railroad shipment, there was flasks or barrels that had cracked. So frost damage, we definitely see cases related to frost damage and pipe bursts and all of that. There was a man running from a dog who broke his leg in this 1922 article. And the question was whether the rain was responsible. So obviously personal injury and slip and falls are a lot of what we see today. And the other one was lightning that I pulled, and whether it was, an act of God or due to a thunderstorm was that particular question, but we use lightning data today as well. So a lot of the questions are very, very similar. 1925, I always like to show this article because this one talks about a case that involved a river and some dredging that had been done, and there was a lawsuit related to where the high and low water mark was. And I put this one in the presentation because I wanted to point out that one of the things that I do pretty routinely in cases that involve hydrology or buildings, sometimes you're working with other experts. So you might be working with an engineer, you might be working with an architect, in this case, maybe a hydrologist. So there's a lot of not just communication from scientists to people who aren't scientists, but you're also working with other experts who have different languages and different ways of communicating. So sometimes getting information across it's always interesting, just, communicating with people who do different types of science. So there's a lot of interdisciplinary work as well. And that was obviously the case 100 years ago. This is more recent in that it's like in my lifetime, at least. So I put this one in here because this Delta Airlines flight 191 back in 1985 was really one of the groundbreaking cases in terms of forensic meteorology. Just to give you some context, the flight was going to Dallas and there was thunderstorms in the forecast, and the plane crashed just shy of the runway on landing. So in this case, the meteorologists came in and they were actually able to reconstruct computer simulations of what they were hearing at air traffic control and what they were seeing as they were coming in for the landing, and what was going on with the radar, as you can kind of see in that middle panel. So it was one of the first times that computer graphics were used in court. It was determined that the plane flew into a microburst, and so the visualizations kind of helped explain that to the court. Let me show you, just give you a little side if you're interested. If a plane is flying through a microburst, you can see on the left-hand panel there, it's a really fast-moving downward column of air associated with a strong thunderstorm, hits the ground, spreads out like a pancake in all directions. And so you get that sort of ring that you see in the inset panel of the left-hand side. And so when a plane flies through that and they're coming down for a landing, they first encounter a headwind, like you see on the right-hand panel, that lifts the nose up. And so the pilot will, of course, drop the nose to compensate. But then as they cross the microburst and they encounter a tailwind, that lowers the altitude very quickly, which is why these planes hit the ground just shy of the runway. So one of the good outcomes of this kind of work is that now there's mandated crew training and an FAA warning system in place. And so these kinds of weather-related accidents on landing at airports due to microbursts don't really happen anymore. Another question I get asked a lot is whether I see criminal cases. Only a couple, very, very rarely. Most of the cases I deal with are civil in nature, but once in a blue moon. There's actually a famous case. There's a book about it here, and Bill Haggard was the CCM on this case. There was a man on trial for murder of his wife, and she had hit her head falling down some stairs about 3 o'clock in the morning. And the husband's alibi was that he was relaxing by the pool for the last several hours, wearing shorts and a t-shirt. And so Bill Haggard in this scenario, he took weather data from surrounding weather stations, interpolated it to the location of where the incident was, and was able to conclude that the temperature was falling through the 50s. So as part of the whole case, this finding contributed to the defendant being found guilty, because you wouldn't be sitting by a pool in the 50s. Maybe some people would, but I definitely would not. It's a book. So there's a book written about it. I put the picture of it there if you want to look that up. And it's also a Netflix series, which I have not seen. I think it's called The Staircase, but it's like a mini series. So you can follow up on that as well if you're interested. So that's the history of the field, and it goes way back. What do I do in my day-to-day is kind of what we're going to talk about next. So the first thing that any project that I start with is always finding data. And it's always observations. It could be any type of data. We'll go into a lot of the different types. But the type of data that you use and which selections you make, as far as, you can't use all the data everywhere, or you'd be there for hours and your client would be out of money by the end of that time. So you have to choose the best data set on which to formulate your opinion. And you have to justify that to the court. So finding appropriate data is foundational to making your opinion and doing your research. And it's something that we spend a lot of time on, is finding appropriate data. So I'm going to go over some of the common sources. You've probably heard of some of these, and then we'll talk about kind of how we piece it all together, and I'll give you some case examples. The first one is the federally operated automated surface observing systems. Those are the ones that are usually found at airports. If you open your weather app, you probably get like the nearest first order weather station. And if you're looking at weather conditions, for example, we can get 5-minute data, we can get 1-minute data. They're quality controlled, they're maintained, there's good documentation. The problem with this data is that they're usually near population centers, and they're pretty sparse as far as the spacing around the country. So here's an example of what a surface weather map might look like. You can see each of the stations are plotted, and I blew one up here for you on the right, just so that way you can see what the numbers look like. And there's temperature in the red, dew point, pressures on the right, the winds and the cloud cover are all plotted. And then those station data are used to create these surface weather maps. So this is great for getting a big picture of what's going on, and also looking at the individual data from individual stations can help us figure out timing of what's going on a more local level. But you see, for example, like where I am in upstate New York, the spacing between these stations is not ideal when you're looking at something that's not in a city where people, where it's very populated. So we look for other data. The National Weather Service Cooperative Observer Program is a great one. It's made up of over 8,000 volunteers, and it was started back in 1890 under the Organic Act, which also started the National Weather Service. This is run by the National Weather Service, so it's their equipment is used or meets their standards. It's quality controlled, but you only get data once a day. So you usually get high temperature, low temperature, snowfall, snow depth, precipitation. It's great for those once daily reports, but you don't really get a lot of intermediate data, such as hourly. So there's downsides to every data set. Another one that we commonly use, you may be familiar with, and some of you in the audience may even be observers, part of the CoCoRaHS network, Community Collaborative Rain, Hail, and Snow Network. This one's a newer network. It was started out in Colorado in 1998. Again, once daily observations. These are trained volunteers, and you can see an example of the rain gauge that's used on the bottom panel there. It's great. It's a low-cost observing system, and it's relied on by meteorologists all around the country for verification, what's going on the ground, and keeping track of, weather in real time. So it's a lot like the Cooperative Observer Network. It's nationwide now, and I think it's actually in Canada as well. I put on the top panel there just so that you can get an idea. Those are the rainfall observing stations that reported during Helene, and some of those stations in the red were over 20 inches of rainfall. So these were invaluable, and these observers really were diligent despite really, really difficult circumstances. So it's a great network. There's a lot of training online, and it's archived at NOAA at the national headquarters, so that way we can get it easily and get it certified. New York State and some other states have what we call mesonets. So they're not federally run networks, they're state. There's some federal funding in the New York State Mesonet. But I put this up here as an example so that you can see that the density or closeness of the observing stations is much greater than what we have for the federal ASOS sites. So this in particular, but other mesonets as well, they're fantastic at filling in holes. We get 5-minute data. There's camera imagery from north-facing cameras at most of these sites, and that's really helpful. It's like another set of eyes on the ground. So you might suspect that there's freezing rain based on nearby observations and the radar, but if you can see ice accreting on a chain link fence, then you really have a very good feel for what's going on the ground. It's a newer network again, so pretty much all these stations were available beginning in 2016. And they do offer a certification, which is important for court as well. Certified records, they have more of a likelihood of being accepted pretty readily without much contest in a court proceeding. Here's some other ones. On the top right there, you see the underside of a radar. So the dome is what you would usually see. And underneath there is the instrumentation. So that is what is sensing precipitation in the atmosphere, precipitation type. It can sense winds above as well when there's precipitation particles. So it can help us with analysis of winds when we have cases involving severe weather. There's algorithms that can identify whether there may be large hail present and things like that as well. So radar is invaluable. On the bottom left, you see National Weather Service watches, warnings, and statements. And this isn't really so much a piece of data that we would use like an observing station at the surface, but piecing together a chronology of what was known when and what kind of information people would have had access to and what decisions they made with that available information is a lot of times at the heart of what is the lawsuit. You know, somebody did something or made a decision to do or not do something that resulted in somebody else getting hurt or killed. And so piecing together what was available in terms of watches and warnings is something that we do routinely. The middle panel on the bottom is lightning data. So you can see with pretty good precision where the cloud to ground lightning strikes were using the National Lightning Detection Network. And then if we're looking at precipitation, we're always comparing it to long-term statistics using NOAA Atlas 14. And that will tell you the return period, whether it was a 1 in 100-year rainfall or whether it was a 1 in 50-year rainfall, for example. So once we determine how much rain fell, that helps to place it in historical context. Incidentally, there's a new NOAA Atlas 15 that's in the works that does take into account some newer information and trends in rainfall. So the point here, however, and I think I kind of made this clear with some of the maps that I've already shown you, is that, as you can see from this quote from the bulletin of the AMS in 1971, it doesn't happen that the data is where the incident happened. And that's why meteorologists are brought in, right? I mean, if the data is right on the site where the incident happened, even then you might need a meteorologist, but usually you're interpolating between stations. I've had a few that have happened on airport sites. And even in those cases, you could be 2 or 3 miles from the actual ASOS observing station. So that's why forensic meteorology exists. So the considerations that we make when we're looking at all of these data sources, is it available? Is there missing data? Is it incomplete? Did the volunteer observer go on vacation? You know, there could be any number of reasons why data is missing. Is it representative? I live in New York State. We have mountains, we have valleys, and where I live in just outside of Troy, New York, I am at about 400 feet elevation. The nearest cooperative observing station is about 1.5 miles away from me at 11 feet in elevation above sea level. It's right on the Hudson River. And we have vastly different weather conditions, even though the stations are very close to my house. Is it documented as far as how the site is maintained, how the data is quality controlled? All of that's important to the court. How much does it cost? You know, we have to pay for lightning data. So if there's no thunderstorms involved and there's no reason to get it, obviously we're not going to be getting the lightning data. Is it necessary? Do you need it for that type of analysis? Maybe, maybe not. And the certification, which is offered by both the National Center and some state mesonets as well. Again, that really certifies to the procedures by which the data is collected and maintained. And so that makes it a little bit easier to get it certified or accepted into court. So we talk to the attorney, we figure out what the problems are. What do they need to know? Sometimes they don't know what they need to know. And that's always a really interesting conversation too. Just finding out, I know the weather's important here and I know it's going to become an issue in this case. And then you kind of have a conversation about maybe what kinds of questions might need to be answered. And you set up a project to help answer those questions. So then we do our data analysis and then we put everything into a chronology, which I'll show you in a second. So we'll dive in. I'm going to focus on 2 case examples for tonight, and then I'm just going to hit on a couple of other just to give you a flavor for like what kinds of things I see. One of the most fun things about what I do is that you never know what's going to walk in the door. It could be really interesting. It could be the same storm that you've seen 15 other times in other cases, but maybe, where the accident happened is different, or the time of day was different, or the time during the storm was different. Every single case is different. And I think it's one of the most fun things about what I do. So slip and falls, I'm in New York, so we see a lot of slip and falls on snow and ice as part of our work here. And this one in particular made the news. It happened on a Sunday morning and it caused gridlock on the New York City road system, the interstates. There was ice. And so obviously, that created problems. It wasn't even a weekday, but there was a lot of accidents. So it made a lot of national headlines as well as local headlines in the New York City metro. So this person slipped and fell, and we were approached by the plaintiff's attorney. And the questions are the same, regardless of whether it's the plaintiff's or the defendant attorney. They need to know whether there was pre-existing old snow and ice that might have melted and refrozen, creating a problem. Somebody was negligent maybe and didn't clear, or whether there was an ongoing storm, in which case the defendant generally isn't liable. They don't really have a liability to clear or duty to clear until after the storm ends. And you can define after. Sometimes it's not as black and white as you might think, just because how storms tend to occur. So this particular case, the plaintiff fell at about 7:30 in the morning, which you can kind of see on the top right of the timeline here. But it's important to go back and set the context. So going back in time is something that we do routinely, looking for potential old snow and ice, etc. Well, what was key in this case was that it was really, really cold leading up to the incident. And that allowed time, several days, for the ground to freeze solid. So the night before, or the afternoon before, there was a freezing rain advisory that was issued by the National Weather Service at 3:30. Remember, this incident was at 7:30 the next morning. The bottom line here is that if the apartment complex owners had just put some salt down, there was only like a couple of hundredths of an inch of glaze, but it solidly glazed the steps. So there was an advisory that was in effect. There was a lot of unraveling of the weather forecast that night because it wasn't clear whether temperatures were above or below freezing. And so you can see there's a series of statements here that were issued and reissued by the National Weather Service overnight. Precipitation began, excuse me, about 45 minutes before she fell. And then after that time, once they realized that, there was widespread ice, the freezing rain advisory was later reissued again after that. And in this case, we had some conflicting eyewitness testimony as well. So the plaintiff testified that there was precipitation occurring at the time, which did end up being consistent with what the weather records showed, and that she saw the glaze on the ground, but only after she fell. The defendants, the owner of the building and the superintendent who was there on site, they didn't have a clear chain of command based on their testimony. They only used one type of rock salt. They didn't use like a calcium chloride based salt, and it was kept in a completely inaccessible location. He couldn't even get to it that morning. They stated that they didn't check weather warnings. They said that they treated the night before, but with a couple of hundredths of an inch, that was kind of debatable. So you just kind of put that out there and say, well, there was only a couple of hundredths of an inch. So, it depends on whether there's treatment logs, which in this case there weren't. And so there's a lot of discrepancies about what was done when. But the bottom line is that morning, they didn't salt until right shortly before or after the time. And I don't think he had reached the area where she fell yet. So they take all of our information and they put it together with their motions, and eventually, you know, the case will either settle or go to court. But my role is not to advocate here. Like I said, you know, I just put the weather information in a timeline for them to use and understand and kind of help develop their case strategy. Sometimes there's bad news to deliver to a client as well. I get that question. You know, sometimes it's just not favorable for their case, and they need to know that as well. It's information. So sometimes there's inconsistent eyewitness testimony. Sometimes the testimony doesn't match the weather record. This case, there was a really difficult weather forecast, and so there was changing warnings and statements that were being issued overnight. But the bottom line is that, you know, there was a warning out the night before or the afternoon before, and had there been salt put down, it probably wouldn't have caused a glaze on that part of the sidewalk. Another example here, localized flash flooding. This is something that we see, I would say, with somewhat increasing frequency since I've been doing this since 2013. I have a kind of a small sample size because I'm a small business, but we're definitely seeing more of these kinds of cases. Excuse me. So this one was in central New York, and the property owner was suing the county. There was a culvert that was, I think, like right across the street, that basically took a stream and moved it on the other side of the road. Well, the property was flooded during a very heavy rainfall event, 3 feet up into the first floor. So there was tons of damage. There was maintenance that was done or not done to the culvert. So there was obviously issues with this particular culvert, and that's why there was a lawsuit. I was retained by defense counsel, and it was because he actually had some conflicting testimony between his own engineer and the plaintiff's engineer. So they didn't have any meteorologists. I'm sorry, one of them might have been a hydrologist. I'm looking at this now. But in any case, there was a hydrologist and or an engineer on either side. His expert was trying to do runoff calculations. So he was looking at this and trying to figure out how much rain fell. So the plaintiff's expert used a nearby CocoRoss site, those once daily volunteer observers, and he made some errors in how he interpreted the data. Again, you know, if you're a meteorologist or you're not, you're trained in interpreting the weather data versus somebody else who might not be. He assumed that they were calendar day totals. They're not. They're generally taken at 7 a.m., the observations. And so he stated, well, it's not possible to determine exactly when that rain fell. It is possible if you do a radar analysis. So that's what the plaintiff's expert was saying. The defendant's expert, the one who hired me, he found some news reports that said there was like 4 inches of rain in 30 minutes. And he said that the flooding would have happened just regardless of what was done or not done to this culvert. So the attorney came to me and he's like, I don't know how to reconcile this. Can you help me? And yes, we can. So we go into the data. The incident site's kind of that big star. It's a little bit blurred over just to kind of block the site specifically. But you can see this is great. This is why the New York State MESNet and all these other data sources are so helpful, because you can see even in rural central New York, we have a pretty good data network where we can look at observations of precipitation. I'm going to just let this loop very quickly so that I can keep moving. But what you'll see here is on the radar loop, you can see there was rainfall. And if you look at the different weather observing stations noted by the dots there, you see this is typical for convective or thunderstorm rainfall. It doesn't hit all the sites in exactly the same way, right? Some of them had very heavy rainfall and some of them didn't. So the question then becomes, what happened near the incident site? So we can take radar data and plot accumulated precipitation. And that's what I did for where the radar is estimating precipitation falling over time at all of these nearby observing sites, and then comparing it to what actually fell on the ground. Those 2 red lines where you see a lot of rainfall going up, one of those is right at the incident site. And one of those is I pulled out where the most rain fell, just for reference to see where the peak was sort of over the whole map. Well, it turns out that if you look at this map, the blue pixels to the right are where the heaviest rain fell. That was right in the watershed of where this incident happened. It turns out that the CocoRoss observer that the plaintiff's expert used was less than a mile away, but not in the same part of the watershed, and didn't even get the rainfall. You can see just to the south, there's much less in the green shading. I don't have a scale there for you, but that's much less rainfall. And so what we can see here is that the localized rain, which fell, that resulted in this flooding event at the site, fell just east of the incident site, not south, where the plaintiff's expert was relying on one piece of data. And, based on the analysis, was able to determine that it wasn't probably 4 inches, but most of the precipitation fell in between 1.5 and 2 hours. So we found some information that was very helpful. This one actually did have to go to court, but it actually settled the day after I testified. So, they brought me out and I testified, and then that was it. I'll skip through this one pretty quickly. This just shows where the damage reports were. And you can see that, they're widespread because this was a little bit widespread of an event. So there was, different damage reports around, but there were some that were really close to the location of the incident. So that particular batch of heavy rainfall that impacted the incident site did result in damage as well. I think some bridges washed out. So we were able to piece together everything and determine that most of the rain fell about 5 miles to the east over a 1.5 to 2 hour period. There was probably 4 inches in that maximum, but not at the incident site. And so that was kind of a clarification that his own expert had said that it was, 4 inches. And then in the immediate watershed, there was at least a widespread 3 inches in just about 2 hours. But that one CoCoRaHS observer that the plaintiff's expert relied on wasn't representative of what happened at the site because the rain didn't hit it the same way. There was much less rainfall there. So those are 2: flooding, slip and fall, hail. This is a neat one. This is in the southeast, and the day after a hailstorm, there was still hail on the ground, and the temperatures were in the 70s in March. There was hail damage to the structure, and we had to go in and determine how much hail fell and when and the timing. And there was an airport site that was really close, about 2.5 miles away. And it turned out it wasn't representative at all. The radar analysis was key in this case in determining that there was a downburst that hit the site that didn't hit the airport weather station. This one is cool. If anybody in the audience remembers the Springfield tornado, this one I was more brought on as like a context expert. They really just wanted to know what happened and talk about the Fujita scale and talk about how damage assessments are done. So talking about the historical context. So really just what happened was important, but everybody knew that this was a big tornado. It was more just talking about and explaining some of the tools that are used and some of the ways that damage assessments are conducted and what the Fujita scale is and that kind of thing. So it was really providing general weather information in the context of this tornado specifically. There was a case I was brought in to talk about snow fences. There was snow that was drifted across a highway and caused a motor vehicle accident one day after a snowstorm. And there were some allegations that trees were put in that basically created a snow fence that caused that drift across the highway. So I had to go in and explain how a snow fence works and how, in this case, the trees kind of acted as a snow fence and allowed the snow to drop where it shouldn't have otherwise. So that was an interesting case as well. Again, just kind of explaining different types of phenomena to the court and to the jury or to the judge if it's a bench trial. Lightning. Was a fatality caused by lightning? Was it caused
Hey,
by...
Alicia,
Yes.
sorry to interrupt. Maybe it's my screen. I might be one slide behind, or you may be one slide
Gosh.
behind.
Yeah, let me see that there. Hey, I'm sorry about that.
Oh, it's
How about...
it
There you
just
go.
started happening. So that's the tornado.
Well, thanks for
And
jumping in.
then, yeah, no, because I really
How's
wanted to
that?
see this too.
Can everybody
Yeah.
see the lightning?
Yes.
Okay, awesome. I'm so sorry about that.
No, you're good. It just happened.
Didn't realize. Thanks for jumping in. Am I still doing okay on time? I'm
You're
just...
great. Yep.
Okay, awesome. I thought you were going to tell me I was out of time, so I was really going to have to rush. Okay, so yeah, lightning. And the question there was whether, it was lightning or winds that caused the tree that fell on the car that caused the fatality. So we're looking deep into lightning and radar analysis. Another interesting one, this is the one criminal case that we had in recent years, and it involved, I'm sorry, there's 2, but this was one in particular, and it involved how long a can had been in the snow. And it was a really old case because it was with the Innocence Project. And so the conviction had happened in like 1992 or something like that. So we were digging way back into really old radar maps and trying to figure out what happened in terms of how much snow fell. And it was really interesting. It was difficult because of the data network back then, but it was really interesting. Another one, we have a lot of these types of really high impact weather events happen and cause pileups on highways. It could be fog, it could be snow squalls. I'm dealing with one right now in particular, and weather can change very rapidly. So even if there's warnings out days in advance, if traffic's allowed on certain highways, these kinds of accidents can still happen. And so just timing out everything that happened as the incident was occurring and prior to that is really important, especially when there's so many different parties that are involved. So really super interesting. Like I said, I hope I gave you kind of a flavor tonight of just some of the different types of cases that I get. But like I mentioned, you never know what kind of question people are going to have about the weather and how you can help them find the answer that they need. It's just one of the really cool parts about what I do. So I'm always looking in the past, like I said, I have my husband, I should disclose, works for the National Weather Service here. So I ask him about what the weather's going to be doing any day. So I'm looking always in the past. And sometimes the weather is like a key factor in the case. Sometimes it's just a supporting role. And then the data, like I've talked about, that's so important. So understanding like how to obtain and analyze all different types of weather data and know which ones are really appropriate and the best choices to use for any particular case is really crucial. And that's just foundational to forming a good opinion to give the court the information that they need. But most cases settle out of court, which is good because going to trial is not always easy and it's always nerve-wracking. So I will end it there. And thank you guys for having me. And I am definitely happy to take questions. I think we have time, so.
Definitely. Yeah. Thank you so much, Alicia. This is fascinating. Of course, I have my own questions. I'm going to hold back a little bit to try and get to as many as possible. We have quite a few questions already in the Q&A button
Brian,
there
do
in
you
your
want
Zoom
me
screen.
to,
So
sorry, do you
yeah,
want me to stop the screen share? So,
but you can hold up there for another minute in case folks want to reach out. Yeah,
oh,
by
no
all
problem.
means. Otherwise, yeah, you can stop sharing in a second here. I want to make sure people have a chance to take down your info.
Sure thing.
This is great. Please get your questions in. We'll try and get to as many as we can. And certainly, please feel free to follow up with Alicia with her availability to the best of her ability, because I'm sure you get all
Definitely.
sorts of interesting inquiries.
Yeah, feel free to reach out.
I appreciate that. Well, I mean, let's just kick things off. Actually, the last one, just very briefly, this is my own question. I'm being a little selfish here, but you're just making me think a little bit toward the end here. We here in Mount Washington and in the White Mountains, we engage a lot of recreationalists, and there's obviously folks who get into trouble because of weather conditions, their injuries that occur there. Have you had experience or know of other forensic meteorologists who have worked in cases investigating more like recreational or even outdoor recreational type like forensic meteorology?
Yeah, I mean, I've had a few of my own over the years. Unfortunately, they're really difficult to work on because usually somebody's hurt or killed very badly as a result of a decision that was made. So usually, at least in my experience, the ones that I see are, for example, with like a scouting group or, if somebody's making decisions on behalf of others and guiding a group, that's where there's some liability issues that arise if somebody gets hurt.
Oh, I bet. Yeah. That's really interesting. Another one, and this comes from anonymous. Was asking. This was really early on, and I wasn't sure whether or not you're going to get to something like this. But has forensic meteorology been used to solve mysteries of the Bermuda Triangle? And I'll even widen that a little further. I mean, how much do you or other forensic meteorologists, to your knowledge, get involved in, basically in oceanography and incidents and things like that out on open water?
Okay, so there's a couple of questions in there. I don't know. I'm not the person to answer about the Bermuda Triangle. There may be somebody out there, but that is not me. So I'm going to defer that one. But like I said, there may be somebody out there who's looked into it. We do see marine cases sometimes, but I'm not a marine forecaster. And so there are people who do marine meteorology who, if there's a case related to a boat, for example, and there was some specific information about winds and waves that were needed, I would defer to an expert like that. So yeah, we definitely do see cases over the ocean, but I don't see them too often because it needs to fall into like my area of expertise.
Absolutely. Yes. Well, too bad. We'll reach out to a Bermuda Triangle expert for the
I
next one
don't
for
even know
sure.
who to refer to.
Yeah. Well, here's a good one from Sandy, who I certainly know, and Sandy, he's a retired New York attorney and he says his negligence partner used such expert testimony in a case, and he's saying I can assume that science was deemed admissible as a result of the Fry hearings, which means very little to me. What does that mean to you, if anything?
Right. So those are the rules in New York State by which experts get admitted into court to testify as experts. You can't just pull somebody in off the street to say what the weather was doing and call them a meteorologist. You have to have credentials and experience, and you have to show that you're using sound data.
Okay, that makes good sense, and also gives me a little bit of comfort as well, if I were ever to be in that situation. We had a couple of really good questions sort of around, broader scale. I know you're talking about meteorology, not necessarily climatology, but both Larry and Trevor were asking questions around where you're seeing how much climate change may be impacting the practice of forensic meteorology. In this case, Trevor is even saying, are you allowed to reference changing weather expectations? Are you restricted to looking largely just backwards in your statements only? And, how much does that limit either your opinion or the validity of other expert claims? I mean, I know you kind of referenced a little bit just in your own sort of anecdotal evidence, a little bit of say the flash flooding events. That kind of spurred me to think, oh, yes, maybe climate change impacts in the Northeast. Yeah, what do you see? What do you think of some of that stuff?
Yeah. So, like I did mention, yeah, just in my own small, I say I'm a small business owner, so it's a fairly small sample size and small practice. We're definitely seeing more commonly litigation that involves these localized high impact flash floods. And those are events that have been shown to, or were projected back, in the early climate models that are showing to increase in frequency over time. And so, especially in the Northeast. And so I think it's consistent with what is projected and what is observed to be occurring. I will say in terms of data, I'm typically looking back. I don't really do any modeling forward in the work that I do. So I'm looking back for long-term trends in long-standing weather stations. Like Brian and I were talking offline before, and some weather stations do have temperatures that are very good. Albany goes back to 1874, and there's other stations around the country that are equally as good and longstanding. In terms of assessing rarity, the rainfall events, I mentioned the NOAA Atlas 14, which is kind of like the standard statistical reference that's used to assess rainfall and how common or uncommon a particular event is over a particular duration of time. They're working on NOAA Atlas 15, which does account for trends and observe trends in rainfall. It's still a ways away, it's in development, but that will eventually reflect what we're seeing in terms of changes in how rainfall occurs today versus, decades ago.
Oh, interesting. Okay. And also, connects really nicely with a question here from Jay, who was kind of curious. So obviously you're looking back, you referenced some of the changes that have occurred in either your industry or other industries as a result of, learning about, like you mentioned, like how a microburst may affect, if a plane is in the vicinity of landing or taking off. Jay was curious, like, are your services ever used for highway and bridge or other sort of infrastructure development, or what sort of, connections there may be between your work?
Yes, so not personally, but yes, there are, firms that do that kind of consulting. So I'm definitely not one of them, but you could certainly do similar types of analysis and provide information. And I'm sure there's projections involved in those kinds of analyses as well. Even in terms of setting, like, for example, that culvert was built to withstand X amount of rain and last, say, 30 years. And so, they're looking at coding and zoning and all of that in terms of how do we build infrastructure that can withstand what may occur. So
Okay.
yeah, I'm sure there are consultants out there that do that. It's just not me.
Yeah. Oh, sure. Well, it's amazing how specialized you also can get, and even all the specialists you've mentioned and that you've worked with, and that takes a village clearly to investigate some of these things. Yeah, great question from Dana here, is asking, how do you access old radar data? I know I have my kind of go-to site, but what are the tools that you're usually using, I guess, in that context to look at historical radar?
So this is actually, I'll put in a plug for the government here. The National Center for Environmental Information is the agency which is responsible for housing a lot of our weather data. And they maintain a long-standing archives. They're actually located in Asheville, North Carolina. And so they suffered greatly personally during Hurricane Helene, and there was some data outages at the time, but they were able to recover all of the paper, the old paper records. But that's sort of the go-to source for getting archived weather data. There's not a lot of sort of freely available, well, I mean, that's free, but there's not a lot of easily accessible sites where you can just go to like Weather Underground and get archived radar data. There you can get weather station data at a lot of different places, but as far as radar, I would definitely go to the government.
Yeah, no, that's all right. That makes me feel good. There's no secret then. I use that as well. So good.
Yeah. Yeah.
Yeah. Yeah. Well, I mean, speaking of some of those data points, I'll give the shout out here, Mike Hansen, who's saying, hey, as a CoCoRaHS observer, I just want to amplify just how amazingly localized weather events can be. What is reported regionally is often very different from what occurred at a specific location and time. And he's happy to contribute his little data point. And I'll just say I know lots of other folks and use CoCoRaHS all the time to verify even our cooperative weather station here and all that. And it's amazing just one side of the town from the other. And like you were showing, especially those localized flash flooding events and other things, it's incredible what can get missed also.
If there's any other CoCoRaHS observers in the audience, I need to thank you guys. Yeah, we rely on you. And I've given some talks to CoCoRaHS specifically, actually recently, similar to this one where we talked about it. And the comments that they include with their reports are sometimes invaluable in just sort of depicting like, oh, it was really hard to take the observation today because the winds were so strong. Or, there's slushy puddles over here, but the deck is really icy. Or, these little things that don't seem to make a huge difference when you're going back to try and figure out what happened. You can look at the radar and, look at the observations and this is what you think is going on. But if somebody actually sees it and writes it down, that's another piece of information that really helps solidify your conclusion.
Yeah, 100% for all things, I'm sure, both major and minor, to try and reconstruct those things. Well, all right, Alicia, I think time for one more question. I know we got lots of other really wonderful questions here, and hopefully folks do follow up, but hopefully an easier one, because you've said you've had to answer this one before. I know you mentioned the Fujita scale. Could you just clarify that for folks who aren't familiar with and have a love of tornadoes?
Sure thing. Yes. So in the Fujita scale, it's now called the enhanced Fujita scale, was developed back in the 70s by a pioneer researcher, Ted Fujita. And it is a damage scale to assess tornado strength. And so it was strictly damage based. Now it's, it assesses the wind speeds and also the integrity of different types of structures as well. So now it takes into account whether it hits, for example, a structure that's on a foundation versus one that's not, et cetera. So it goes from 0 to 5, 5 being the strongest. And if you look up Fujita scale online, you'll find like loads and loads more information about the history of it and how it was developed.
Oh, yeah, awesome. Thanks, Alicia. Appreciate that. And then the subtle differences between that and the hurricane rating scale and all those things, always really interesting. All right, well, Alicia, you're welcome to stop sharing your screen here. And while I say thanks to some folks, I want you to also appreciate in the Q&A here, lots of CoCoRaHS observers coming out of the woodworks here to say thank you as well. And lots of other folks expressing their appreciation. I know I'm really grateful for you to share your expertise tonight. And for everyone else who joined, thanks so much for joining tonight's free program. Definitely encourage you, if you enjoyed tonight's program, make a donation to help support programs like these over at mountwashington.org. You can find the donate button there in the upper right-hand corner. Also, if you have thoughts about tonight's program, want to share some more praise, constructive criticism, by all means, there's a survey that I'll follow up in the Zoom window here and also in our thank you email that goes out tomorrow. And then finally, don't forget to join us for next month's Science in the Mountains program on Tuesday, March 11th. That's also at 7 p.m. We'll have research scientist Megan Collins from the Desert Research Institute, and she'll be sharing all about the Mountain, Rain, or Snow Citizen Science program. So we hope you'll register for that program. Watch any of the previous ones you may have missed over at mountwashington.org and search for Science in the Mountains. And we'll see you all again soon. And thanks again, Alicia. Have a great night. Thank you. And hope you come for a visit sometime soon.
Absolutely. Thanks so much for having me.
Yeah, have a great night. Take care, everybody.
Bye.